when we talk about combining functions, we're just talking about taking two functions, and we've got function rules for them, and we're going to add them, subtract them, multiply them, divide them. And then there's going to be one new thing, which is called composition. That's going to be the one piece that's a little bit tricky for us today because it's something brand new. And then some of trig functions is going to be, they're really calling that a separate topic. That's obvious. So just one thing that's going to challenge us a little bit. So as we get started here, if we have two rules, so f of x is, I don't know, x squared minus 7x plus 4, g of x is square root of x plus whatever. They give us some function rules for those. If it says create a new function, f plus g of x, that just means take the f1, take the g1, add them together. Same thing with subtracting, multiplying, dividing. Those are all going to be pretty obvious. If they say find f plus g of x, so you still got a variable, that means get a new function rule, a new formula that still has x in it. But if they say find find fg of 3, that means plug 3 in and get a number. When we do the division one, we do have to be careful. We have to check for the domain and make sure g of x isn't 0. If g of x was just by itself, it'd be okay for it to be 0. But if we start dividing by it, if we put it in a denominator, we have to make sure it isn't 0. In general, on all of these, the domain is going to be the most restricted. If f is something that 2 doesn't work in, even if 2 works in g, I have to throw 2 away for any of these where I put them together. If there's something that doesn't work for f, it doesn't work for f plus g, or f divided by g, or f times g, or any of the ways of putting it together. So if it's restricted once, it's restricted in the final thing. The new one that's a little bit tricky to get the hang of is what we call a composition of functions. We're going to take one full function and plug it into the other one. This looks like fog, but we don't read it that way. I don't want to hear anybody say it that way. We read it as f of g of x. And the order matters on these. So it's going to be a little bit easier, I think, if you look at that and you read it, oh, f of g of x. Oh, I can write that as f of g of x. So I know that we're f of 5, I put a 5 in there. F of whatever goes inside of there. If we turn it around and start with g, that means g of f of x, so it's g of, and then put f of x inside of there. Most of the time we will get different answers. We will see in a few more lessons, special cases, we actually use it as a test. Do we get the same thing when we do f of g of x and g of f of x? And not just that, do we get 1 as the final answer no matter which way we do it? That's going to really help us with something down the road. But we're not ready for that yet. First we just have to start understanding how we plug things out. So let's start trying some examples here. And I want you to write f of x equals x plus 3, g of x equals x squared plus 1 down, and then don't recopy that again. You're going to see it at the top of every single one of my slides. I'm going to use this all the way through this lesson. I recopy it just so I can still see it, but yours is going to be on your paper. Save yourself some writing. Just write it this one time. This one says we want to get f plus g of x. So since there's an x there, that means we need a new formula that has an x in it. So to do that, we are going to say that this needs to be equal to the formula for f of x plus the formula for g of x. So we simply copy the x plus 3 plus the x squared plus 1. And then we say, oh, I've got any like terms we can combine, and let's put this in standard order. So we have x squared plus x plus 4, and that's our new rule for f plus g of x. So that's not bad. We can handle that. Now, if they ask you now, the formula is the f plus g formula, plug 4 in. Well, right here is my f plus g formula. So all I had to do is plug a 4 in for that x and say that I need 4 squared plus 4 plus 4. I'm just plugging it into my formula right here. So 16 plus 8 gives me 24. Now, if our homework problem had not given us part 1 first, if the homework problem just said f of x is x plus 3, g of x is x squared plus 1, find f plus g of x, we could have simply said that that is f of 4 plus g of 4, and we could have looked at our formulas up here. F of 4 is 4 plus 3, and g of 4 is 4 squared plus 1. So 7 plus 17 is 24. So we could have just plugged the 4s in and added things together. I told you this was pretty straightforward. Okay, let's do this one where we're dividing. So this one wants a rule with an x in it. So we're going to take the rule for f, put that in the numerator, the rule for g, put that in the denominator, and we have x plus 3 over x squared plus 1. This is division, so I need to ask myself a couple of questions. Can I factor that denominator to be able to simplify anything? I don't think so. And then I need to worry about, oh, is the denominator going to be 0? So let's see, x squared plus 1 can't be 0. X squared can't be negative 1. Does any real number cause a problem with that? So we have no restrictions, so the domain is still all real numbers. We're good. Okay, now let's find f over g of 2. Well, we have a rule now, so all we need to do is to plug the 2 in for all of these x's. So I have 2 plus 3 over 2 squared plus 1, 5 over 5, so I just got 1. Okay, we'll do a subtraction one, and then we'll do start doing our compositions. So this one says, oh, just find f minus g of 1. So I could simply plug in f of 1 minus g of 1. So f of 1 is going to be 1 plus 3 minus, got to make sure I subtract this whole thing. So I'm going to put my parentheses there, 1 squared plus 1. So I'm looking at 4 minus 2, which is 2. if you preferred, and when you start doing these in the lessons, some of you are going to do them one way and some are going to do them another way. If you preferred, you could have said, I want to get a rule first. So my rule would be x plus 3 minus my entire g, x squared plus 1. So I had to distribute that minus sign, x plus 3 minus x squared minus 1, or minus x squared plus x plus 2. Then if I wanted f minus g of 1, I'd have negative 1 plus 1 plus 2, and I could get 2 that way. Either way is correct. So thumbs up, thumbs down in the middle. How do we feel with the plus minus times divides? Okay, let's try compositions. So first thing I'm going to do is to rewrite this without the little circle F because it helps me see more clearly which way I'm doing this. This is f of, and then g of x. So that means I need to take the f rule over here, and where I had an x, I need to put in g of x. G of x is x squared plus 1. So that means I'm doing f of x squared plus 1. Now, if this was f of 5, you know that means change every single x in the formula to a 5. 5 plus 3. If it's a 7, it means change every single x to a 7. When we do f of x squared plus 1, that means change every single x that we had to an x squared plus 1. So I have to change this x to an x squared plus 1. But then I still have that plus 3. So this becomes x squared plus 4. And that is my new f of g of x rule. Let's go the other way. Let's do g of f of x so you can start to see that the order makes a difference. So this time, I am doing g of f of x. So I am doing g of, back where I can see, f of x was x plus 3. So f of x is x plus 3. So if I'm doing g of f of x, I'm doing g of x plus 3. That means I have to go over there to my rule for g, and I need to put x plus 3 where I had an x before. G of 2 means change every single x to a 2. G of 3 means change every single x to a 3. G of x plus 3 means change every single x to an x plus 3. Have to be a little bit careful with this. This is not x squared plus 3. This was x times x plus 1. If I am changing every single x to an x plus 3, what I have right here is an x plus 3 times an x plus 3, and then I still have that other plus 1. So then I just FOIL this, and I have x squared plus 6x plus 9 plus this other one. So I have x squared plus 6x plus 10 is my new rule for g of f of x. If the book asks you more than one thing in the same problem, I need them labeled which one is which. If it asks you to find f of g of x and g of f of x, you've got to label which is which like I just did. If it just asks you one thing, it's obvious which one thing you found. Okay, now with compositions, what if instead of f of x of f of g of x, we said f of g of 3? There are going to be two ways you can do this again. You could say that that simply means f of g of 3. Well, let's figure out g of 3 means change the x to a 3. So g of 3 is 3 squared plus 1. And that's what we need to take f of. So we need f of 10. That says come over to the rule for f and make every x a 10, so that we have 10 plus 3, or 13. Yes. Thanks for checking. Okay, or in number 6, I came up with a rule for f of g of x. So I'm going to go back and look at my rule for f of g of x was x squared plus 4. So f of g of 3 would be 3 squared plus 4, which is also 13. That finishes the composition. That just leaves us to add two trig things together. Questions with the composition? Okay, last one for today. And I'm not sure why they think we need a separate topic for this. They've been having you find things like draw your special right triangle and find square root of 6 times the tangent of 30. And they've had you do problems, draw your special right triangle and find 2/3 times the sine of 60. And now all they're doing is saying add that together, and I think you would have guessed without it being a separate topic. Do each part and then add your answers together. 30, 60, 90 I can do in one triangle, so I draw it. Need to label all 3 angles and all 3 sides. So then I am looking at root 6, tangent of 30, SOHCAHTOA, so opposite over adjacent for the 30, what's that, 1 over root 3? And I know I can't leave a root 3 in my final denominator, but I'll worry about that as I go along, what do I need to do with it, if anything. And then sine, so that's opposite over hypotenuse, but this time I need to use the 60. So what do I have, root 3 over 2? So my 2's cancel, so I have root 3 over 3 for that part. And somehow I got to clean this up, but that's root 6 over root 3. So that's going to be the same as root of 6 over 3, or root 2. So I could leave my answer like that. Or if I especially wanted a common denominator, that would also be okay.